What is up, YouTube? And welcome to another video. Now in this video we're going to be talking about performance engineering with containers, so Docker containers, and specifically CPU analysis. Now I made a video in a previous video about CPU analysis using flame graphs and how to visualize CPU usage and understand what is chewing up CPU. In that video we used a technology called perf events, which is basically a profiler for Linux called perf. Downside of that is that perf is very chatty with user space and kernel space as the kernel does all the frequency counting, and then so there's a lot of back and forth. Now also the other downside is, you probably saw in that video, when you're profiling like Java or .NET, you have to copy the perf maps out of the environment you're profiling and into your environment where you can analyze it and build flame graphs. Now there's been a couple of attempts in the Linux kernel to make this process a little bit better by doing some of the compute inside the kernel using kernel modules, but that's also a bit dodgy because the writing kernel module, you have a high chance of panicking the kernel, and also it's not very well sandboxed. So what is BPF? BPF is exactly what we want. We want to be able to execute code as close to the Linux kernel as possible. Now BPF is not a relatively new technology, but what it allows you to do is send bytecode to the Linux kernel, and the kernel compiles and runs this bytecode inside of a hypervisor. So it has like a VM inside of the kernel. So it's super fast, super efficient, and it's also sandboxed. Now in the past, to monitor network activity, a tool called TCP dump uses BPF to basically compile bytecode, send that to the kernel, and then monitor network traffic that way. So it is extremely efficient. Now this BPF technology has been extended, and it's now called eBPF, which no longer is restricted only to packet filtering, but also to disk I/O, memory, CPU profiling, and much more. So if you're a DevOps engineer that basically looks after Docker containers, Kubernetes, and Linux environments, I highly recommend you check out flame graphs. You will see in this video, we will take all these BPF tools, we'll put it in a container, and we'll use that container to profile a system where we have a dodgy microservice that is eating up all the CPU, and we're going to even point to the line of code that's using all the CPU. Now the IO Visor has a GitHub repo, and they make it really simple for us to run BPF tools on our systems without having to understand the eBPF technology and how to transform basically bytecode and things like that. So they have a GitHub repo called BCC Tools, which is all compiled eBPF applications. And if you take a look at this repo, there's a tools folder, and inside the tools folder is all these applications. There's BPF trace, there's like CPU utilities, there's network TCP dump, file system utilities, and a lot more. So we're specifically going to be taking a look at the profile utility, and we're going to put that inside of a Docker container and then use that container to profile microservices on Kubernetes. And this is really useful because I don't like installing anything on my operating systems. I don't like installing anything on production servers because it does increase the attack vector, and it also leaves a lot of utilities and backdoors open on the box, because these types of utilities have to run with elevated permissions because they're talking to the kernel. If we take a look here, I have a Docker file for all these tools. Now the BCC, if you follow the documentation, you'll see that they do most of their things on Ubuntu. So I'm going to grab an Ubuntu Bionic base image, and then we're going to install some dependencies. We need Perl to do flame graphing because the flame graph tool is written in Perl. We're going to need Git to pull out dependencies, and here is the IO Visor BCC tools repo. So I'm going to go ahead and add that, and then I'm going to apt-get all their dependencies that they need. So one caveat that you need to know is that in order for this BCC tool to use BPF to the kernel, it has to have the right Linux headers package. So if we run uname -r on our machine, you can see down here that this is the version of the kernel I'm running here. And basically what the BPF tool does is it uses lib modules. So if you do ls on lib modules, you should see the same one. And this inside of the container needs to match the uname on the host. Otherwise, yeah, it's not going to work so well from within a container. So if you're going to plan on running this in the cloud, make sure you SSH into that machine instance and get the right Linux headers package for that machine. Okay, more on this later. So if I go down here, we're git cloning the FlameGraph utility. We're also git cloning the BCC tools I showed earlier. Now here is how to get the Linux headers for BPF in the cloud. So this is an Azure VM, for example. So I went onto my Kubernetes cluster and I did a uname -r, and I found out this is specifically the version of Linux headers I needed for this. So if you enable these lines, you can go and curl that, and then you don't need to use apt-get to install it. It's not necessarily always that simple to just run apt-get and install the Linux headers, because in the cloud, not all cloud providers open up their package repository, so you're not going to be able to just apt-get it. So you can see down here, I curl it instead. And then we're just going to have an entry point to run bash. And this is going to be our FlameGraph container that we can run on any container host to start profiling. Now I have this entire GitHub repo. Everything I'm about to show you is on GitHub. Link is in the description. It's going to show you an example FlameGraph, how to get the tools. So this is a Docker image I showed you earlier, how to pull it. Then I also have a sample dodgy .NET application and a Golang application that we can profile in this. And to build and start that up, all you're going to do in this repo is clone it and do docker compose build and up to start the application. And there's two options. One of my previous videos I did perf. So if you want to go ahead and use perf and perf events and learn more about that tool, there's an example there. Or you can just follow my eBPF example here, which shows you exactly how to start up this profiler. So if you clone that repo, you do docker compose up-d, and I'm going to run a sample.NET application here. And while that's running, I'm going to run htop. And we can see here that our application running says, let's say this is a production server, and we can see that CPU is being used. It's quite high, 100% on this .NET application. So you get to the production server, you see this, and you're like, okay, what's going on? What is this application actually doing? So now that I'm on that system, I can run our FlameGraph container. So you have to run it in privilege mode. I'm also running PID host so that I can see processes. I can run top inside there, just really helpful. And then what I'm also going to do is I'm going to mount volumes to allow BPF to work, and then I'm also just going to mount the network so I can look at the network as well if I wanted to. But there's the Docker container, and if we go ahead and run that, now we're inside of that container. Now I can either profile the entire system, or I can just profile that process. So I'm going to say ps-orgs grep.net, because I know that this is the .NET application that's running high CPU. I'm going to grab onto that process ID. And then we're going to start running our profiler. Now to run the profiler, if I do ls inside the container, we can see we have FlameGraph and the BCC tools. So to run this, I can just say /BCC tools. I can run the profile.py, and I can profile this on a frequency of 99. And I can also say I want to profile for 15 seconds. And I also want to pass in the process ID. And the process ID is 6763 in this case. That is enough to profile, and then I want the profiler to spit out the data, so I'm going to pipe that into FlameGraph and the FlameGraph Perl application, and then I'm going to redirect that out to our out folder that we mounted into the container, and I'm just going to call this perf.svg. So this will go ahead and profile the application, send the data to FlameGraph, send that out to a scalable vector graphic, which we can then visualize in a browser or an image viewer. And that will tell us exactly what is happening on CPU. So now with that done, I'm going to head over to the file system, and we have perf.svg here. And I'm going to open that up with another application. Now I can use Firefox or Chrome. The browser is generally good at viewing this type of application. And here we go. So this is the application .NET. We can see there's 1,400 samples, and basically the wider the flame graph is, the more busy that function is on CPU. So you can see in our case here, the entire application width is spent just doing our program. And if we look up the stack trace, we can see there's a program and a main method, and then there's a class called busy with a method called stay busy. Now that is code that I wrote that's intentionally bad, so that we can see this through a flame graph, and this will point us to exactly that function that is causing this. What I can do now is I can go to that program or microservice, and I can look at the source code that I saw in the flame graph, and here we see there's a class called busy and a method called stay busy with some infinite loop, which is some bad code. So running this type of profiling will help you identify what code is really hot on CPU. Remember, the width of the flame graph is showing you the most samples, and the higher the samples, obviously the busier the CPU is. Now, it's important to note that for programming languages like Java, .NET, and Node, for performance reason, the runtime does not emit all the details of every function call and method to the kernel. So like the method names and things like that, because that's kind of for humans to interpret. So that is left out by the runtime for performance reasons. Now what you need to do is you need to turn those kind of things on. So for .NET, there's an environment variable called com+perfmap enabled. So you need to enable this on your microservice if you're running .NET before it will start giving those events to the kernel. Otherwise, you will see, if you look at this flame graph, you can see we can see the actual class and method names. You'll still be able to see these lines in the same width, but they'll just be unknown. So these names and labels won't be shown. They'll just be unknown, kind of like this here, where you see the unknown. So you won't be able to identify your line of code. So it's important to turn on this environment variable in order for .NET to emit those debug CLR detail to the kernel. So I hope you guys enjoyed that video. Hope it was useful. Now, if you're a DevOps engineer, make sure you check out flame graphs, check out perf, check my video on perf events, as well as try out the eBPF tools and start using flame graphs and identify performance bottlenecks on your systems today. So hope you liked the video, hope that was useful. Like and subscribe, and until next time, peace.